Okay, let's talk about inertia. Let's talk about inertia. So inertia is a property of matter. If you've seen Bill Nye the Science Guy, you know what I mean. Um, it's just a property of matter that an object that is at rest tends to stay at rest. An object at rest tends to stay at rest. If an object is already moving, that object will continue to move with constant speed in a straight line. So an object in motion will continue with constant speed in a straight line. That's just the property of all matter. And Galileo called that inertia. Uh, Along came Rene Descartes just a little bit later and made a couple corrections to, or at least one correction to Galileo's version of inertia. And then Isaac Newton wrote it down as his first law of motion. Isaac Newton's first law of motion is called the law of inertia. Why was why was Galileo studying inertia? Well, back in his day, remember that he was trying to convince people that the Earth really was moving around the sun, the heliocentric model of the universe proposed by Copernicus. Well, people thought that that was ludicrous. They just thought, there's a bunch of reasons why they thought that was crazy. But amongst them was that Aristotle had said that if you want to move something, you have to apply a force. Imagine me pushing my textbook across the front desk. I have to apply a force with my hand to move it, and as soon as I take my hand away, it'll stop moving. Therefore, Aristotle incorrectly states that all motion requires a force. Again, that's wrong. You know that's wrong. If you are playing air hockey on an air hockey table, in order to get that little air hockey puck to move, you hit it, but you don't have to keep touching it to keep it moving. You just have to hit it once, and it goes off without you touching it anymore. It'll just keep on going and moving until it hits something else. That's this part down here. Unless acted upon by an unbalanced force, it'll just keep on going. If I were to take this whiteboard marker and go out into space and just leave it, and out into space way far away from any gravity, and just leave it, then an object at rest tends to stay at rest. I could come back a million years later, I'd look really old. It would still be there. If I take the whiteboard marker out in space and there's relatively no gravity, and I throw it, it leaves my hand, it will continue moving with constant speed in a straight line because there's no force there to cause it to speed up or slow down or turn. That's a property of matter. We measure inertia by measuring an object's mass. So I have more mass than you do, so you'd say I have more inertia than you do. Can you have inertia if you're at rest, like you're lying on the couch? You just don't feel like getting up? Yeah. Do you have the same amount of inertia if you're moving in your car towards Starbucks? Yeah, because it's a measure of your mass. Don't confuse inertia with momentum, because momentum, as we'll learn later, is mass times velocity. And when you're at rest on your couch, you have zero momentum, but you still have your inertia, which is measured just by your mass. All right? When you're moving on your way to Starbucks in your car, you have more momentum because you're not at rest anymore. You have the same amount of inertia as you had earlier. Okay, inertia. And we're going to talk a lot more about that as time goes on. Why was Galileo studying inertia? Because people again thought that the Earth, well, he said that the Earth is moving around the sun, trying to support the heliocentric model of the universe, Copernicus. And in order for that to be true, of course, the Earth has to be moving. How can the Earth be moving if Aristotle says that there has to be a force present to actually move the Earth? Where's that? What's pushing the Earth so that it moves? That's specifically why Galileo was studying inertia. Nothing's pushing the Earth to make it move. The Earth is moving because it's already moving, and for no other reason. All right? It's a property of matter. The Earth was already moving, and it will continue moving because there's nothing to stop it. All right? Unless it runs into some humongous other planet or something. It'll just keep moving. there are a bunch of other arguments again. Okay, what's causing it to move? Where's the force coming from? Well, there isn't. That's why he was studying inertia. People say, well, if the Earth is spinning, then why isn't it windy outside? Well, because the air itself is also moving, right? Along with the ground and you and everything's moving together. What they also said, we'll study this a little later on, if the Earth is spinning, why don't we get thrown off the Earth? That's an interesting question. It turns out that it would have to spin about 17 times faster for that to be a problem. Anyhow, coming back to this, inertia is a property of matter. So let's see if I can get this to work. I shouldn't even try this because it probably won't. Okay, I've got a penny and a piece of paper. The penny is at rest. I'm going to apply a quick force to the paper. It's just a card, 3x5 card. Ready, steady, go. Oh my goodness, it worked. All right. The penny's at rest, tends to stay at rest. I applied the force to the card, and the card went sailing out from underneath the penny, not the penny. Again, there just wasn't enough friction to get that penny to move. An object at rest tends to stay at rest. Okay. All righty. Next question. Unless acted upon by an unbalanced force. Well, I'm going to try to increase the brightness here. Probably mess it up. Hold on. Where do the forces come from? Good question.